This is May 2015 Standard Level Paper 1, Time Zone 1, Question 6. And it's a question about the discriminant. And using the discriminant to make statements about the roots of a quadratic. So we've got a quadratic here. In fact, I don't want to do that. We've got a quadratic there. And we're going to use the discriminant. B squared minus 4ac. Usually call it capital delta. And the question is, in this quadratic, what's a, what's b, and what's c? A is the coefficient of the x squareds, b is the coefficient of the x's, and c is the constant term. So let's look at a first. A is just the coefficient of x squared, p in this case. B is the coefficient of x, so that's already done for us. 10 minus p is b, and then c is the constant term. This is where you're likely to make a mistake if you're going to make it. The constant term is all of that. This is the bit that doesn't involve x at all. So let's substitute in what we've got into this. So instead of b squared, I get 10 minus p squared minus 4 lots of p times c, which is 5 quarters of p minus 5. So we can evaluate that. Before we do so, I'm just going to, oops. Oh no, we're just going to colour coordinate it. I've colour coordinated it wrong. Oh, there we go. Sorted. That's that bit, that's B. There's A, and there's C. So let's evaluate it. 10 minus p squared is not 100 minus p squared, it's not 100 plus p squared. You get 10 minus p times 10 minus p. Minus 4p. I've not really done anything there. I just really want to emphasize that this bit here, when you square a pair of brackets, you get your cross terms, first outside, inside, last. Smiley face method, however you do it. So that you get 100 minus 10p minus 10p plus p squared, or 100 minus 20p plus p squared. The other bits are easier to expand out, but you must watch out for these negative signs here and here. Minus 4p, the first bit, times 5 quarters of p. 4 times 5 quarters is 5, so that's minus 5p squared. And the other bit, minus 4p times minus 5 is positive 20p. Now I've got positive 20p here, it's going to cancel with these negative 10 minus 10. So there'll be no p's, which should not surprise you, because in the question they told us what we were trying to get to, 100 minus 4p squared, and it doesn't have any p terms in it. And we're basically done at this point because we've already got the 100 there, equals 100. I've got plus p squared minus 5p squared there. So 1p squared minus 5p squared is minus 4p squared. And that was given in the question. Let's have a look what part B says. Find the values of p so that f of x equals 0 has 2 equal roots. 2 equal roots. Another way of saying that is to say, well, it's got one real root When does that happen? That happens if, when you do the quadratic formula, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. When you use that formula, you've got the plus square root and the minus square root. You get the same answer only if that square root is 0. So if you add b squared, the square root of b squared minus 4ac, you'll only get the same answer as subtracting b squared minus 4ac if that's 0. I'm going to write that down here. Here's the quadratic formula. Struggling to squeeze it in. That's meant to be a squared there. There we go. So that gives you two answers. It gives you two answers because of the plus or the minus here. Usually those two answers are different, but if the square root is equal to 0, then they will be the same. So if the discriminant is equal to 0, then we get two real roots. Sorry, one equal root. One real root, two equal roots. Oh dear, I'm trying to move this and it's just, oh, disaster. Ignore that line, it's not meant to be there, it doesn't tell you anything. So, we've worked out the discriminant. Even if you've made a mistake, if you couldn't get this answer, you can still answer part B because we know the discriminant, it's told to us in the question. And basically all you're doing is solving the equation, when is that equal to 0? And that's fairly easy to do. 100 is equal to 4p squared. Divide both sides by 4. You get 25 is equal to p squared. And to take square roots, you get p is equal to plus or minus 5. Now that should not be surprising because, let's pop that out of the way back up here, you will notice it said values of p. Values, plural. So you should expect your answer to be at least two values of p. And with a quadratic, you're probably expecting to have exactly two answers because of what we know from our lessons in quadratics. So that's that. Plus or minus 5.